All right, to keep going, we're going to tie in how we relate the rectangular equations and the polar equations and their coordinates and how they're kind of tied to each other. So taking a look at this triangle that we have formed over here, it's got the polar stuff in it, it's got theta, it's got r in it, it's got the rectangular coordinates in it, x and y. The relationship between them, kind of thinking about not unit circle, goodness gracious, right triangles. If this is a right triangle, we could say the tangent of whatever angle theta we're talking about is equal to y over x. Thinking about tangent, so we know SOHCAHTOA, tangent is opposite over adjacent. So that theta is, the tangent of that theta is the y value over the x value. Now also thinking about r in relationship to x and y, again, this is a right triangle. The right triangle, if you've got two legs of a right triangle, thinking about good old Pythagorean Theorem, a squared plus b squared equals c squared. In this case, a, we're going to call that x squared, plus our b value, the other leg, is y squared, equals the hypotenuse squared, r squared. Doing a little bit more with polar and the rectangular coordinates, think about the equations. The sine of whatever angle we're talking about is equal to the y value divided by the r value, the opposite over the hypotenuse. The cosine of theta is equal to the x value over the radius. So the adjacent over the hypotenuse. Now this is all going to tie in to help us figure out how to get the coordinates for these. So our coordinates in rectangular, we want, let's start with x. We're just used to going with x. X first and then y. We're going to take the equations that we have on the left side and convert those into equations that are just involving x and involving y. Taking a look at those four equations, I would say the easiest one to get x all by itself would be this bottom one down here. This bottom one down here, if we multiply both sides by r, we'd get x all by itself, and it'd be x equals r times the cosine of theta. Similarly, to get y all by itself, I'm going to use this equation down here because I just multiplied both sides by r, and we get y equals r times the sine of whatever angle theta is. So if we know our radius and we know our angle measure, we can figure out the x and y coordinates. Now, to go get our polar coordinates, you want to get theta all by itself and we want to get r all by itself. Taking a look at the previous equations again, up here in the rectangular equation, we got tangent of theta equals y over x. If we take the inverse tangent of both sides, so the inverse tangent of theta will just give us that theta we're looking for. And the inverse tangent of x over y, we're just going to express as the inverse tangent, sorry, not of x over y, of y over x. Now, we want to get r by itself, so going back again to the rectangular equations, we have x squared plus y squared equals r squared. To get r all by itself, we take the square root of both sides. So we get r equals the square root of x squared plus y squared. We're going to use this information to come up with, or to kind of interchange between rectangular and polar coordinates. So down at the bottom here, we are given some coordinates. Again, this is in polar coordinates, so we're given r and theta, and we're asked to convert them into x and y rectangular coordinates. So we're going to use the equation that's x equals r times the cosine of theta, and let's just start there. So we got x equals 2 times the cosine of pi. Now, I'm going to go on a limb and say several of us, myself included, don't always remember every angle on the unit circle. So I'm going to give you a copy of the unit circle. I'll post it on Google Classroom as well. Make sure you can reference that. If you don't remember what the cosine of theta is, go back and look at the unit circle. Now again, sorry, the cosine of pi, I should say. Look for angle pi. There it is. Now taking a look at x and y, cosine is your x value, sine is your y value. So in this case, the cosine of pi is -1. So it's going to be x equals 2 times -1, which gives us the x coordinate of -2. Our y coordinate is r times the sine of whatever angle theta is. So we got y equals 2 times the sine of that same angle pi. Again, going to the unit circle, we find pi. Hey, we were already looking at that. Look at the y coordinate. That's where we find the sine of an angle. So we have y equals 2 times 0, which is, well, 0. So the x and y coordinates of A are -2, 0. Let's try another one together, and I'll have you do the last two, or I'll encourage you to do the last two on your own. Going with the x coordinate, we got x equals radius, square root of 3, times the cosine of pi over 6. So we got x equals the square root of 3, the cosine of pi over 6, again to the unit circle, pi over 6, right here, cosine, square root of 3 over 2. So we got square root of 3 times the square root of 3 over 2. The square root of 3 times the square root of 3, you can simplify that if you want to the square root of 9 over 2. Well, the square root of 9 over 2 is, well, 3 over 2. I'm going to say let's just leave it at that. Y equals r times the sine. So r, again, sorry, square root of 3 times the sine of whatever angle is, pi over 6. So we got y equals square root of 3, again, going to the unit circle. The sine at pi over 6 is 1/2. So we have square root of 3 times 1/2. Cleaning that up a little bit, we're just going to make that the square root of 3 over 2. So the x coordinate, 3 over 2. Y coordinate, square root of 3 over 2. I'd like you to take a few moments, try out C and D on your own, pause the video, come back to it, and I'm going to pretend that you paused it because I'm going to go out on a limb and say many of you didn't. Oh well. X coordinate for C. We got x equals r, 1, times the cosine of 5 pi over 6. So we got x equals 1 times the cosine of 5 pi over 6. We find 5 pi over 6. That's over here. Cosine, negative square root of 3 over 2. So we got 1 times negative root 3 over 2. So giving us an x coordinate of negative root 3 over 2. Y is r, 1, times the sine of 5 pi over 6. So we got y equals sine of 5 pi over 6, 1/2. So we got 1 times 1/2. We get y equals 1/2. So we have negative square root of 3 over 2, 1/2. If you didn't pause between B and C, pause so you can try between C and D to see if you can D all by yourself. And I'm going to again pretend that you paused. We got x equals negative 3, our r value, times the cosine of 5 pi over 6. I feel like we just did that, which we did. We got negative 3 times the square root of 3 over 2. Well, there's not a whole lot we can do to clean that up. If it helps you, and I kind of glossed over this earlier, if it helps you to think of it as negative 3 over 1 times the square root of 3 over 2, we're going to make it negative 3 times the square root of 3 over 2. That's as clean as we're going to be able to get that. The y coordinate, let me switch back to blue. We got y equals same r value, negative 3 times the sine of 5 pi over 6. So we got y equals negative 3 times, we got the sine of 5 pi over 6 earlier, it's 1/2. So we have y equals negative 3 over 2. So the x and y coordinates here, we got negative 3 root 3 over 2, comma, negative 3 over 2.